In this video, I will explain how to find the nth term in an arithmetic sequence. So the formula that we can use to find the nth term of some arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. Now, I have a couple examples for us to work through here. So let's take a look at the first one. We have the sequence of numbers 3, 7, 11, 15, 19, and we're asked to find the ninth term in this sequence. So to find this ninth term, we can just use this formula that we have up here. So we'll say a, now instead of a sub n, we'll write a sub 9, since 9 is the nth term that we're interested in. A sub 9 is equal to a sub 1 plus n is 9, 9 minus 1. Now this d is the common difference between each of the elements in the sequence. So the way that we find that is we say, let's take a look at the first number, 3. What do we need to add or subtract to get to the next number in the sequence? 7. Well, we would need to add 4. Now, how would we go from 7 to the next number in the sequence? 11. Well, we would also need to add 4. And to go from 11 to 15, we would add 4 again. To go from 15 to 19, we would add 4 again. So we can see that the common difference, or the d, is 4 in this particular sequence. So we would say multiplied by 4. Now, a sub 1, this is just the very first number in the sequence. So that's 3. So what we can write is a sub 9, so the ninth element, or the ninth term in the sequence, is going to be equal to 3, the first number, plus 9 minus 1, that's 8, times 4. 8 times 4 is 32. So we would say a sub 9 is equal to 3 plus 32, that's 35. And if we want to double check that this is correct, here we have a sub 1, that's the first number, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6 would be 19 plus 4, that's 23. A sub 7 would be 23 plus 4, that's 27. A sub 8 is going to be 27 plus 4 is 31. And then lastly, a sub 9 would be 31 plus 4, which is 35. So that matches the number that we got down here. All right, let's take a look at our second example. We have the sequence 4, 10, 16, 22, 28, and we're asked to find the 51st term in this sequence. So we'll use the exact same formula that we used in the first example. So let's write it out. We have a sub 51. It's going to be a sub 1 plus n, in this case, is 51. So 51 minus 1 times d. So d is the common difference between each of the values in the sequence. So let's take a look. This first value in the sequence, we have 4. How can we get to the next value of 10? Well, we would need to add 6. Now to go from 10 to the next value in the sequence, 16, we would also need to add 6. To go from 16 to 22, add 6. And to go from 22 to 28, add 6 again. So our common difference in this particular sequence is 6. So we'll go ahead and write a 6 for d in our formula. So now we can write a sub 51, so the 51st term, is equal to a sub 1, so that's the first term. So we see that's a 4. So we'll write 4 plus 51 minus 1 is 50 times 6. 50 times 6, that's 300. So we would say a sub 51, or the 51st term in the sequence, will be equal to 4 plus 300. That's 304. And that is going to be the 51st term in the sequence. So again, we just use this formula up here in the top left corner to solve both of these problems. Thanks for watching, guys.